Hello everyone, class 12th and topic is Gattermann reaction for haloarine. Name reaction again. In previous video we have understood Sandmeyer reaction with its mechanism. Now we have Gattermann reaction. First, Gattermann reaction can create which haloarine? Same like Sandmeyer. It can create chlorobenzene and bromobenzene, but not iodobenzene and fluorobenzenes. They are not possible. Reason already I have discussed in Sandmeyer reaction. Same here, because Gattermann reaction is also happening with free radical mechanism. So reason for non-formation of iodobenzene and fluorobenzene I have already discussed in Sandmeyer reaction. You can check there. Now let's check the mechanism behind it. First condition. Gattermann condition is just similar like Sandmeyer reaction, only little bit difference is there, only a minor difference is there. In Sandmeyer reaction, you were using CuCl and HCl to produce chlorobenzene. This one, benzene diazonium chloride was the starting material, CuCl, HCl. This was Sandmeyer reaction. Now, if at the place of CuCl, you are just using Cu, copper, so the reaction will turns to Gattermann reaction. Similarly, if you want to create bromobenzene, so use this condition, copper and HBr, bromobenzene will generate out over here, like this. Let's go for the mechanism. And also we need to heat it. These chemicals and heat them, bromobenzene and chlorobenzenes will generate out. Let's go for the mechanism. Mechanism is just similar like Sandmeyer reaction. Here we have unstable benzene diazonium chloride. Nitrogen, again I am writing these nitrogens. This nitrogen making triple bond, so obviously it will carry a lone pair. This nitrogen is making 4 bond. Out of 4 bond, 1 is coordinate bond. That's why it is carrying +1 charge. This +1 charge is balanced by -1. Now copper, what copper is doing there? Copper is providing 1 electron like this. Same like in previous reaction. There we were Cu plus 1 and Cu plus 1 was giving electron to become Cu plus 2 like this. Same here. Copper is going to provide 1 electron and it will turn itself to Cu plus 1. Now where this electron will go? Toward positive particle. It's a negative particle. Electron is a negative particle. Obviously it will go toward a positive particle. Here we have a positive particle. In the presence of 1 electron, this nitrogen firstly will make itself stable. How? By gaining pi electrons toward itself. Now when it will gain pi electron toward itself, what changes will arise? Look, on this nitrogen, lone pair will generate. Double bond will come here. Nitrogen, this nitrogen now will have a vacant orbital with a +1 charge. Because in this bond, 1 electron was of this nitrogen. Now it is shifting toward this nitrogen. So nitrogen will have a vacant orbital with a +1 charge. In this vacant orbital, who will enter? This electron will enter. Due to which this benzene diazonium free radical will generate, which we call benzene diazo free radical. Benzene diazo free radical. This one. This is azo group, diazo group. Now, how this unpaired electron will get satisfaction? Obviously, neighbor nitrogen, in this bond we have 2 electrons. The neighbor nitrogen will break bond from carbon and will shift its 1 unpaired electron here, and 1 unpaired electron will come here and bond formation will happen. And from here bond will break. Due to which you will get phenyl free radical and this nitrogen gas will eliminate out in its normal condition like this. Lone pair on this nitrogen and only one lone pair will left on this nitrogen, N2 gas. Now what about this free radical? Let's check what will happen with that. Same like Sandmeyer reaction. Now phenyl free radical is generated over there. With Cu, we also have HCl over there. Cu has done its job. It has provided one electron which we have utilized. Now it's a turn of HCl. H positive, Cl negative. Now because during reaction free radical is generated, it can be satisfied by only a free radical. So chloride will change itself into a free radical like this. Chloride have one extra electron. That extra electron it will release out. I have written it here, and will turn itself into chlorine free radical. Now this chlorine free radical and phenyl free radicals will combine to give us chlorobenzene. Unpair electron will make sigma covalent bond. This is sigma covalent bond. Covalent bond. Chlorobenzene is generated over there. Now what about this extra electron? This extra electron will be absorbed by our copper ion, which was in +1 oxidation state, and will return back itself to copper. Like in Sandmeyer reaction. In Sandmeyer reaction, Cu+1 change itself to Cu+2 and again returned back to Cu+1. Here also, copper firstly change itself to Cu+1 and then again it will change itself to Cu after end of the reaction. Similarly, if you want to create bromobenzene, only one little bit change you need here. At the place of HCl, HBr will be utilized. Same Br anion will generate, which will turn itself to Br free radical. Now this Br free radical will attack on phenyl free radical and bromobenzene will generate, and one electron which is extra will go towards Cu+1, will give back Cu, and finally you will have three products with you. Bromobenzene and nitrogen gas and copper as it is. This one. This is the mechanism that we have for Gattermann reaction. Iodobenzenes and fluorobenzenes are not possible. Reason already discussed in Sandmeyer reaction video. Thank you very much. In next video we will find out Balch-Seaman reaction. This is the end of the video.